Question number 6. The list of positive integer with exactly 2021 distinct positive divisors can be written in the form of m times 6 to the power k, where m and k are integers and 6 is not a divisor of m. What is the m plus k? So this is talk about the number of divisors. So we already learned this. If a positive integer n can be written as the prime 1 to the power of a1 times prime 2 to the power of a2 prime n to the power of an. So we know the number of divisor we call the tau of n. So actually it can be written the a1 plus 1 times a2 plus 1, then times an plus 1. Right. So this is the formula about the number of divisors. Okay. So in this question, we find that the number of 2021 actually is a product of two prime numbers. They are 43 and 47. So with this information, we can imagine this number, we call it n. This n must be can be written as p to the power of 2020, right? P is a prime. So in here you can see there's a 2021 divisors. Or we can write n equal to a prime p to the power 42 times a prime q to the power 46. All right, so this n can also be written in a form of m times 6k. So this indicating that this number n has two prime factors, 2 and 3, because 6 equal to 2 times 3, right? So then a n must in this form. So we can see n equal to p to the power 42 and times q to the power 46. Okay, so and also you can find out 6 k and where m and k, look at these sentences, are integers and 6 is not divisible by m. So this only tells us, so m can only consist one of the factor, either 2 or 3, but cannot have both. If I have both, then this m gonna divisible by 6, right? So now we can just see, let m equal to 2 to the power something times 6 to the power k, or we can write 3 to the power y times 6 to the power k, right? But you know, x and y must be the same. In this case, we want to find the least of n. Then the least of n must be in this form, right? So then we can write n equal to m times 6 to the power k, so which equal to 2 to the power x times 2 to the power k times 3 to the power k, right? So this equal to 2 to the power x plus k times 3 to the power k. So remember, this must in this form, p to the power 42 and q to the power 46. So it's not hard to find k equal to 42, and then x plus k equal to 46. So find x actually equal to 4. So then we can find m equal to 2 to the power x equal to 2 to the power 4, which is 16, right? So we are looking for m plus k. So we find m is 16 and k is 42. The sum is added together, we got 58. Question number 7. Call a fraction a or b not necessary in simplest form. Special if a and b are positive integers whose sum is 15. How many distinct integers can be written as the sum of two not necessarily different special fractions? All right, so let's find out all the possible fractions. So we can think of from the largest one, we have 14 over 1. So we have then 13 over 2, then 12 over 3, 11 over 4, 10 over 5, 9 over 6, 8 over 7. And they are reciprocal. So the reciprocal is going to be 7 over 8, 6 over 9, 5 over 10, 11 over 4, 3 over 12. So then 2 over 13. And then we have 1 over 14. So from these fractions, we can find the integers first, because any two integers combined, it will give us integer. So which we have the integers 14, we have 4, we have integer 2, that's it, right? Okay, so now we look at here, we have a few numbers give you a simple fraction, like we have 13 over 2. We're going to have same denominator with 2. So which one gives it? This is 3 over 2. And these give us 1/2. Right. So you can see if we have this kind of a same denominator with 2, so we combine those, which might give us the integers, right? Some give us integers, right? So now what else? We have 1/4, but we have 1/4 here. We have 11/4 here. So this 11/4 and 1/4, but they are not going to get any integers by combining these. All right, so I think we can just investigate more. So probably only possible just among those numbers. So now we can just see, can we make 1 with 2 of those? Yeah, we can do 1/2 and 1/2. Right, we can make 1. Can we make 2? We can have 1/2 and 3/2. We can make 2. Can we make 3? Can we make 3? Yeah, we can do 3/2 plus 3/2. We can make 3, right? Okay, so then this and this. So can we make 4? Yep, with at least 2 by 2. So we can make 4. Can we make 5? We cannot make 5. We cannot make 5. Can we make 6? 4 and 2 can make 6. Can we make 7? Yes. So 13 over 2 and 1/2. So which can make a 7. Can we make 8? 4 by 4 give us 8. 9. I don't think so. 10. 11. 11, no, 12, no, 13. Right, we can have 13 over 2 plus 13 over 2. This is good. 14. No, then 15. No, then we can got 16, right? 14 and 2 give us 16. 14 and 4 give us 18. And then we have 14 and 14 give us 28. Right? We can find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Yep, so we go through this list, we find there are 11 possible integers. Answer is C. Question number 8. The greatest prime factor that is a divisor of 16,384 is 2 because this number equal to 2 to the power 14. What is sum of the digits of the greatest prime number that is a divisor of 16,383? All right, so this gives us a number 16,383. So we can write this number equal to 2 to the power 14 minus 1. Right. So we can use the difference of two square numbers formula. So we can notice this actually 2 to the power 7 to the power 2, then minus 1. We can factor this as 2 to the power 7 to the power 2. So plus 1, the sum times the difference, 2 to the power 7 minus 1. Right. 2 to the power 7 equal to 128. So this one give us, this is 129. So times this is 127. So we notice this actually can be factored as at least 3 times 43. So the question is 12 is 127 is a prime, or it can be factored. Right. We can simply check the prime, whether this is prime, divided by 2, 3, 5, 7, 11, and then that's pretty much what we need, right? We can just do one more, 13, right? We can check all the divisibility for these numbers. Now for this divisible is 127 is divisible by non-base. So this actually is a prime. 127 is a prime. Look at this, the largest prime divisor is 127. Then we need to find the sum of digits. That's basically 1 plus 2 plus 7. The sum of digits is 10. So the answer is C. Question number 9. The knights in a certain kingdom come in two colors. 2/7 of them are red and the rest are blue. Furthermore, 1/6 of the knights are magical. And the fraction of the red knights who are magical is 2 times the fraction of blue knights who are magical. What fraction of red knights are magical? Okay, so I think if you invested closely, right, these basically two categories. So one is in color, red or blue. The other is in magical or not, right? So I think these give us a hint. So the good way to organize this data is two-way frequency map, right? So I'm going to show you how to do this, right? So we can have the Question number 9. The night in certain kingdom comes into two colors. 2/7 of them are red, and the rest are blue. Furthermore, 1/6 of the nights are magical, and the fraction of red nights who are magical is 2 times the fraction of blue nights who are magical. What fraction of the red nights are magical? Okay, so if you look at this data, there are a lot of information, a lot of words. So, but basically, you look at the nights can categorize in 2 ways. One is the color, the other is whether or not magical. Right. I think the good way to organize this data is two-way frequency map. Right. You can see this is gonna be the color. We have red or blue. We have magical or not. Right. So let's find this. So total will be 1. Right. So you can see 2/7 be red. So that's basically if you have 2/7 of the nights will be red. So those red can be either magical or not, right? And the remaining part can be 5/7. 5/7 of the nights are blue. Right, so this is the first one. Then we have 1/6 of the nights are magical. So that means this is going to be 1/6 are magical. So the remaining part, 5, 6 are not magical. Okay, so this is the information so far. So now we look at this one. The fraction of right night who are magical is twice the fraction of nights who are magical. So what this means? Okay, so we can just see we can just let the fraction of right night be x. So then the nights of the fraction of the blue nights who are magical. So this be y, right? So this simply just x equal to 2y, right? So this, but what is x? X is the fraction of right nights. Fraction of right nights. Right, so you can see total fraction of right nights is 2/7. Then among these, there's x of these give you the magical. So that's basically, that's 2/7 times x. Or because we know x equal to 2y, we can just write times 2y. Right? So similar, we look at the blue. The fraction of blue nights who are magical. Right? So you can see 5/7 be blue. And out of that, y fraction is magical. So we can write this is 5/7 times y. It's easy to find. We can have an equation because this magical fraction plus this fraction equal to the overall fraction of magical. Right. So we can just write the equation 2/7 times 2y plus 5/7 times y, which equal to 1/6. And we can see this is 4y/7, 5/7, we got 9y/7 equal to 1/6. We can solve y equal to 7/54. Look at the question now. What fraction of right nights are magical? Basically, that will be x, we shown here. So x equal to times 2y. so which equal to 14 over 54. So simplify got 7 over 27. So you can see the answer is C. Okay, question number 10. 40 slips of paper numbered from 1 to 40 are placed in a hat. Alice and Bob each draw one number from the hat without replacement, keeping their number hidden from each other. Alice says, I can't tell who has the large number. Then Bob says, I know who has the large number. Alice says, you do? Is your number prime? Bob replies, yes. Alice says, in that case, if I multiply your number by 100 and add my number, the result is a perfect square. What is the sum of the two numbers drawn from the hat? Okay, so let's look at the first. So there's 40 slips of paper from 1 to 40. There's 40 integers. And Alice says, he draw one. Alice says, I can't tell who has large number. Right? So I think what these tell us. Right. So they tell us Alice cannot have 1 or 40. If she has 1 or 40, you gotta know she has, if the other person, if she has 1, then the other person must has larger number. If she has 40, the other person must have smaller number, she has a larger one, right? Okay, so then Ben got this message. Bob got this message. Bob says, I know who has a large number. This because Ben has this one, right? So I know who has large number. So only when he know he has either 2 or 39. Otherwise, he cannot say that, right? Let's he got 38. He's not sure. X may have 39. He got 3. He's not sure he has larger or smaller, right? Because Alex can have 2 smaller than him, or 4, 5, 6 larger than him, right? The only possible is he got 2 or 39. So look at next sentence. Alice says, you do? Is your number prime? Bob says, yes. Right. Ben says yes. So this Ben says yes. That's clearly show she got 2. 39 is a complete number. 2 is the only prime here. So now we know Ben has 2. So Alice says, in that case, if I multiply your number by 100, so that's going to be 2 times 100, then plus Alice's number, we call x. So the result is a perfect square. We call it n squared. Yeah, we got this kind of defined equation, right? We need to have integer of x, integer of n. And we also know x must be between some number from 1 to 40. Right? Okay, so what x can be? Right, so we notice there are 14 squared equal to 196. So this got greater than 14 squared. 15 squared equal to 225. So 25 could be a possible solution for x. Then 16 squared equal to 256. So here we have x equal to 25. So this gives us x equal to 56. But This violate this requirement. So this is not possible. We can have something square larger number, but not possible because this x is going to be too large. So then we can find the only solution for Alice is 25. So now we have Bob is 2, Alice has 25. We're going to look at the answer. What is sum of the two numbers drawn from there? We have 2 and 25. The sum is 27.